I'm going to resume the recording. All right, so this is going to be day 2. Today is supposed to be test day. So before I actually get started on working out some problems, I wanted to point out some things that I know a few people have been struggling with on, like, how do you use, when do you use what formula? So I want to kind of point out the difference when we talk about the direction of an angle, or the direction angle. They actually just call it the direction angle. That's talking about the direction of the vector. The direction angle is talking about the direction of the vector. And when we talk about that, that's when we use the formula for when they use direction angle. That's going to be my tangent of theta is equal to my y over x. Now, when you have two vectors, you have two vectors. Let me see, here's my two vectors. And I want to figure out the angle between the two vectors. That angle between the two vectors is when we use our cosine of theta is equal to my u dot v over the magnitude of u, magnitude of v. So I want to point out the differences, because sometimes it's, well, when do I use tangent? When do I use the cosine one? So they're just talking about the direction of the one vector. The direction angle is just talking about the one vector. Then you're going to use your tangent. When you're talking about the angle between two vectors, that's when you use cosine. So I just wanted to point out that information because I think that brings some clarity for you guys. So again, direction angle versus the angles between the two vectors. Just kind of a little bit of a summary right there for you guys. So keep those handy because you're definitely going to need those formulas for your test. Let me make sure it's kind of blurry on my end. There we go, a little bit better. All right, well, let's go ahead and let's start off with our first problem. I think this is a great problem because it adds a couple different skills to it. So it says that we have my vector u, my vector v, and my vector w. It wants to know what is the direction of all of this stuff. So I want 4w minus 2 of the quantity, minus 2, the quantity of 2u plus v. So I want to figure out, well, what does this vector look like? When I do all of these operations, what is that vector? And then what is the direction of it? So I'm going to start with what's inside my parentheses first. So I'm going to do 2u plus v. So I'm going to do 2u plus v. So if I want 2u is going to be 2 times 1 and 2 times 5. So it's going to be 2, 10. There's my 2u. So I'm going to 2u plus my v. So that's going to give me 2 plus a negative 3. And it's going to give me 10 plus 3. And I end up with the vector of negative 1, 13. So this vector right here is negative 1, 13. So the other piece then is I want 4w. And again, you could do these, like I kind of am doing little notes up here just to kind of do my different pieces. So my 4w, I'm going to just put it up here right above it. So 4w, it's going to be 4 times 2 and 4 times 3. So my vector 4w is going to be 8, 12, 8, 12. So if I want this whole set right here, if I want 4w minus 2u plus v, that's going to be my vector 4w. It's going to be my vector, my 8, 12 minus my negative 1, 13, right? So this piece right here is this. It's a minus, so be careful because that minus goes to each term. So when I want to figure out what that vector is, it's actually going to be 8 minus a negative 1. And then it's going to be 12 minus my 13. And I end up with the vector 9, negative 1. So this vector right here is 9, negative 1. So this is the vector we're working with. That doesn't tell me the direction of the angle. I need to figure that piece out. So based on this vector right here, the direction of my angle, now if we're talking direction of the angle, we're using our tangent. So I know then that tangent of theta is y all over x. So my tangent, or my theta, is going to be tangent inverse. My y was negative 1 all over 9. I need to make sure I figure out what quadrant I'm in, because remember, when I find this inverse, my inverse is always going to give me something that's in quadrant 1 or 4. But I don't know what quadrant this is in. So is my answer going to match when I solve it? So I look and I go +9, -1. So +9, -1 is my point here. And we're in Q4. That's awesome, because that means if I plug this into my calculator, I'm going to get that answer there. It's going to be in the right quadrant. So when I plug this into my calculator, it gives me that theta is going to be approximately 6.3. Let me double check that that is correct, because I can't read my own writing. So I'm going to do tangent inverse, and I'm going to do -1 divided by 9, and I get -6.3. Okay, perfect. Oops, I said negative, but I didn't write it. So -6.3. That is correct. There's nothing wrong with that answer, except for it doesn't match with any of my answer choices, right? Well, that's because they're using a value between 0 and 360. But remember, if I'm talking about this value, if I'm going -6.3, that's in quadrant 4. That's a valid answer. But I really want the answer so that it goes between 0 and 360. So all the way around is 360. So I just want to minus off that 6.3 value. So it's going to be 360 minus my 6.3, which is going to give me my 353.7 degrees. That's the answer we're looking for. The other piece to this is that I know that this is 90 degrees, this is going to be 180, this is 270. So if I'm in quadrant 4, I know it was going to be one of these two options. I could have easily crossed off those. So you might be able to even eliminate all 3 and you only have your correct answer depending on what answer choices you're given. But remember, finding the direction angle, you're going to be using tangent. And remember, you need to make sure, based on this vector, these values, what quadrant are you in? Make sure your answer ends up in that quadrant. All right, my next one. Given vectors u and v, what is the measure of the angle between the vectors? So now we're talking the angle between the vectors. Up here, angle between the vectors is going to be my cosine. So angle between the vectors is going to be my cosine. So when I look here, I'm going to have, I could do cosine of theta is equal to this, or I could do theta is equal to cosine inverse, depends how you want to write it. I'm solving for that theta, so I'm just going to go ahead and do my cosine inverse is going to be u dot v all over the magnitude of u, the magnitude of v. So I need to find 3 separate pieces to solve this. I need to find my dot product of these two. I need to find the magnitude of u, the length of it, and the magnitude of v. So let's start off with my dot product. So u dot v, I'm going to multiply the first 2 terms together. So it's 3 times 4, and I'm going to add it to the second terms. So times 4 times 3 is going to be my 12 plus 12, which is going to give me 24. All right, so I know my dot product's 24. It's a positive number, so I know that it's going to be an acute angle, or it's going to be less than my 180, sorry. Actually, I know it's going to be acute. So remember we talked about yesterday, pointed out if it was negative, it's obtuse. If it's going to be positive, it's acute. If the cosine value was equal to a -1, then they're going to go opposite directions. So there's multiple pieces. So I know it's going to be acute, so it's not going to be this one right here. But I want to keep working. What if maybe it's something that is undefined? How do I know? We would end up with undefined in the calculator. Let's keep looking at this. So next thing, magnitude of u is going to be the square root. I square the first term and add it to the square of the second term. So it's 3 squared plus 4 squared is going to be the square root of 9 plus 16, which is the square root of 25, which is just going to be 5. Perfect. Magnitude of v is going to be the square root. Square my first term, square my second term. These numbers should look really familiar. So it's a 4 squared plus a 3 squared. They're the same values, so I know that this is going to be just 5. This is 3 squared, a 3 squared, a 4 squared, a 4 squared. They're going to be equivalent. So when I plug all of this in, then I end up with theta is equal to cosine inverse of 24 all over 5 times 5. I would plug this into my calculator and I get theta is equal to 16.3 degrees. Done. So again, this is just in my calculator. All I need to do, plug it in, and here's my answer. Sometimes I think really the hardest part is what formula. So I crossed off this one because for it to be obtuse, so greater than 90 degrees, this would have to be a negative. So that would have to be a negative. So I already know. If you didn't know that, that's fine. But it just kind of goes with the, let me see. 226. This piece right here, where if the dot product's positive, it's acute. If the dot product is negative, it's obtuse. And so just with that idea right there. But if you didn't remember that, you could just plug it in. So you don't have to worry about crossing off options. If you do remember it, then it just helps you eliminate answer choices. Okay, so next one, word problem. This is going to be a work. How do I know it's going to be work? Because they're talking about force. Most of the time we were working in joules. This is just a different type of work because they're talking about the pushing, the distance and the ground there. So it says a wagon is being pulled by a force of 15 pounds. So this is telling me my force, my F, is 15. How much work? Again, they're asking you work is done by moving the wagon 50 feet. So we're going to move the wagon 50 feet. That's the displacement. That's how much it moved. That's what we call our displacement. So they're saying that that D is equal to 50 feet. If the handle makes an angle of 40 degrees with the ground. So this angle right here, this is going to be my theta. Now, if you remember, work is equal to the magnitude of F times the magnitude of D cosine of theta. They gave me everything I have, but sometimes we don't even realize it. Some of you guys are like, well, how do I know that this is the magnitude? Well, that's because if it was the vector, it would have to have that vector notation. So these are going to be talking about that magnitude, and it's pounds per feet, so or foot per pounds, however you want to read it. But that's how that's where these units are coming from right here, because you're multiplying them together. So this is going to be then 15 times my 50 times my cosine of 40. And I just put all this into my calculator. And when I plug it in my calculator, I get an answer of 574.53, and it's going to be foot pounds. Luckily, you don't have to worry about if it's pounds, foot, which one's first, because they give it to you in your answer choices. That's all you needed to do. So don't overthink these ones. Again, if it's not in that format, they'll give you the two vectors and you'd have to find the magnitude, which we can easily do. Oh, that's all I had for you guys today. I thought I had more. Are there any extra questions that you guys have? Clarification on anything? All right. If you guys come up with anything, let me know, send me a message. I think we've got a lot of practice. Again, it was a short section, so I hope you guys do really good on the test. Best of luck, and we will start a new topic tomorrow, matrices. So you guys have a great day. I'll see you. You're welcome.
Thank you.
You're welcome. Bye, dear.